So I'm just going to run through my resource or my digital resource for the demonstrating transition pieces. So mine is just a model made up in SolidWorks. I found this easier to do now than this is better for students, I feel, because you're able to come along here and by using sheet metal, just by flattening out the piece. So that's going to give me the development of the transition piece as such. So it's basically just a hopper. So it's going from one square to another. So that's a transition. So it's transitioning from one area to another. What I can see here, or the advantage I can have here now, when I'm teaching this, is I can come along and can hide my lines. Now, I can still see the outline of the shape, but what I'm trying to get at here is I'm trying to demonstrate the true lengths, because the main problem that we're having in classes is understanding what true lengths are and visualizing them. So if I want to get the true length, I can see, if I want to see if this line is true length, I want to look at this perpendicular. So I'm imagining this is my elevation. This line will be horizontal to will be parallel to the XY line. So that'll mean that line to be a true length in elevation. If I go up to plan of the object, I'll just rotate that the same way. This line again, it's horizontal, or it'll be parallel to the XY, so that means that'll be true length. Now what I can do here again, why I'm using the hidden lines especially, is for these curved or slanted lines here, the diagonal lines here of the hopper. So this line, this is the elevation of my object. This line is at a diagonal, so it's not going to be a true length in the elevation anyway, because it's not parallel to the XY line. Now if I go up to the plan of the object, we can see the same thing. So it's at a diagonal again. If the XY was horizontal, it's not going to be parallel to it. So that means we're going to have to go try and find true lengths of that line. So just to find them, so I'd have to go onto a drawing sheet. I have them kind of already done out. So at the minute, the question I'd be asking here is to find the development of this transition piece, or say of this section here. Now all we're doing is finding the true length of these diagonal sides here, because they're the ones we need to find. So we're bringing a horizontal from 4 in plan, and forget about the elevation for a minute and don't worry about the end view. So we're looking at the plan. We have horizontal from 4, just drawing any length at all, doesn't matter. We're putting our compass here on 4. We're bringing it over to 6. We're swinging an arc up to where it hits the horizontal. We put our pin here on 4 again. We extend our compass out to where it hits number 8. We're bringing that line across. We're swinging that arc up to the horizontal. That hits 2 points here on the horizontal. So now we have 6 and 8 on the horizontal line. We can bring them up to the elevation. So we're up to the elevation now. We draw a line across from 6, 8, or from 5, 7, 6 and 8, we draw a horizontal across there. To where these lines hit that line gives us a point on the true length. Now we go back to our plan. 3 and 4 are the points that are joining to 6 and 8 that we swung from. So 3 and 4 up here in elevation are on this one point, so we can join them back to points 6 and 8 on the horizontal. That gives us the true length. So I have a true length here of 4 and 8, and of 3 and 6, or sorry, from 3 and 8 and 4 and 6. So true length line of 4, 6. If I were to get that now on a drawing sheet, if I was doing it manually, I just get my compass, get the length of that on my compass, and just swing my arc. But I just taken the height of it here, so my height to my true length here is 78.51 for the line 4, 6. If I go over to my development, So if we were to imagine my line 4, 6 is here, we already set up, if I were to draw this out, we have a line we already know at the top is 100 mil long. So this line on the top here is 100 mil, and that can be found if we go back to our elevation. We have it here anyway. Now we have the line 4.6 we had said was 78.15, so we doubled that and it gave us a diameter then for 157.02. So simply what I'm going to do here now is I am just going to, I'll just draw in a circle at the line, or at the size 157.02. I can make that a different layer. For construction. So this will be my true length. This radius of this circle will be the true length of my line 4 to 6. I have another circle here, which was back in the, where we got the true length of it. 3.8 was 95.25. We doubled that because we want the diameter here for the circle. That was 190.5. So 190.5 gives me the diameter of that circle, which the radius then is going to be my, the radius is going to be my true length. So now I have that. That gives me the true length, or the actual length of the sides of the hopper. And then we go about just by getting our dimensions. We know this is the size of, I think it's 30 out here across horizontal. We bring that back and that gives it the shape or the development of this piece in here on the hopper. That's just demonstrating how true lengths are got and what they are.